Hey geometry students, here in lesson 2, we've got a very classic lesson. We're going to be talking about perpendicular and angle bisectors, and we've got the two learning targets. We'll be writing and solving equations, pretty typical, using the two theorems we're going to introduce, the perpendicular bisector theorem and the angle bisector theorem, and then also be able to prove these two theorems and their converses. All right. So if you were in class, you remember the Desmos activity that we did with this one, the perpendicular bisector theorem. So here you've got a segment, we'll call it AB, and then we've got a line that is going to be the perpendicular bisector of this segment, meaning that it's perpendicular to AB and it cuts this in half. We'll call this line P. And so if we put point C here on line P, the perpendicular bisector theorem goes like this. If C is on the perpendicular bisector of AB, so that's the situation that we have here, then, well, here's the situation. This line that I have from C to A is going to be congruent to that point to the other endpoint. So we'll say AC is congruent to BC. All right. So that's the perpendicular bisector theorem, and obviously, the most likely scenario here is you're going to be setting things equal to each other. Now, the angle bisector theorem. So let's say that we take any old angle here, maybe call it angle A, B, and C. And then we have an angle bisector. So we're cutting this angle in half. And let's say that this is point D here on our angle bisector. So we'll say if BD is the angle bisector for angle ABC, but there's more. And we'll say that these two lines right here, this one is perpendicular, and this one is perpendicular. So we'll also say, and AB is perpendicular to AD, and also that BC is perpendicular to CD. Okay, so we got two things really going on here, two ifs. If BD is the angle bisector and these two lines, AD and CD, are perpendicular to their rays, then what do we know? Well, then we can say that AD is congruent to CD. And this is, again, yet another situation where we're just going to set things equal to each other. All right, let's see how this plays out in some exercises. It just says calculate the length of GH. GH is right here. We know that this is my perpendicular bisector. It's perpendicular by that symbol. It's the bisector because I know it cuts this in half. So that means these two things, because G is on the perpendicular bisector, must be equal. So I set 6x minus 1 equal to 3x plus 8. And I go ahead and solve for x. Subtract 3x from both sides, leaves me with 3x minus 1 equals 8. Add the 1 to both sides, I get 3x equals 9. Divide both sides by 3, and x equals 3. Of course, if I need to find the length of GH, I'm just going to plug 3 in right here, and I get 9 plus 8, so GH is equal to 17. I would imagine that not a lot of you are going to struggle with that. All right, moving on. Another kind of classic example here. Calculate the length of LK. That would be this one right here. Well, I forgot to put the marks on here, but this is the angle bisector. It cuts this in half. These are also perpendicular. Those are the two things that we have to have for the angle bisector theorem, which says this is going to be congruent to that. And so, if we want to find LK, well, let's solve for x. We'll say 6x is equal to 3x plus 12. Subtract 3x from both sides and divide both sides by 3, and I get x equals 4, which means when I plug in 4 right here for x, I get 12 plus 12, which is 24. So LK is equal to 24. All right, so that's all good. Writing equations, solving equations, but let's get into the proofs. So here, this would be the proof of the perpendicular bisector theorem. We can see that's the case because I have perpendicular and bisector. It cuts this in half and it's perpendicular. We know that because I have perpendicular lines, that I've got right triangles. Well, I know that I have right angles. So I'm going to call this angle 1. I'm going to call this angle 2. So we'll say angle 1 and angle 2 are right angles. How do I know they're right angles? Well, that would be by the definition of perpendicular. And because I have right angles, I know that I have right triangles. So triangle FG, let's see, I believe this was supposed to be an E. So triangle FGE and triangle GHE are right triangles. How do I know they're right triangles? Well, this would be by the definition of right triangle. Okay, so now that I have that taken care of, I know that I've got right triangles. I only need to find two pieces of information, two clues to get me that these triangles are congruent. Now I've got one of them. One of them's right here, and this is a leg. And so I just need one more piece of information, and that's going to come from GE being congruent to GE. That would be by reflexive, of course. And let's see, this would be the second piece of information that I need, the second clue. This is also a leg. Okay, the hypotenuse being the one on the opposite of the right angle. So both of these are legs. So the triangles are going to be congruent. Triangle FGE is going to be congruent to triangle GHE, and that's by the LL theorem. Now don't stop here. It didn't ask us to prove that the triangles are congruent. The theorem wants us to show that these two things are congruent. And so we can now go ahead and say that because they're corresponding parts. We can say that FG is congruent to GH, and that would be by CPCTC. All right, and there is the proof for the perpendicular bisector theorem. All right, the last one here, the proof of the angle bisector theorem. So we've been given quite a bit. Again, we've been given that this bisects the angle. That's going to be helpful. And we know that we have perpendicular lines. Well, because we've got the perpendicular lines, again, that means we know that we have some right angles. So I'm going to say, call that angle 1 and that angle 2. We'll say angle 1 and angle 2 are right angles. And that would be by the definition of perpendicular. And now because I know that I have right angles, I know that I have right triangles. So I'm going to say triangle JIL and triangle JKL, the two triangles over there, are right triangles. How do I know they're right triangles? Well, again, by the definition of right triangle. The definition being they've got a right angle, and that's what I said right up here. All right, now that I have that, I just need to find two parts. Well, I do know that because this is the bisector of this angle, it cuts it in half. So I'm going to call this angle 1 and this angle 2, And I know those are congruent. Angle 1 is congruent to angle 2 by the definition of angle bisector. And, well, the second thing would just be JL is congruent to JL. Another use of reflexive. So reflexive gets me piece number 2. And because I've said they were right triangles, I only needed the 2. And so we'll say that triangle JIL is congruent to triangle JKL. And that would be, well, let's see, I got an angle and a hypotenuse. And so hypotenuse angle is how I know those two things are congruent. And then finally, I'll finish it off. IL is congruent to KL, and that is because of CPCTC. So that takes care of those two learning targets, and we'll be using these two things in our next lesson.